Let's continue with chapter 5, power in parallel circuits. So like I was saying before, we are going to use the version of power where we have the voltage and the resistor equivalent, quantities, because that's most likely where we are going to have access to. So they give us an example here. What is the total power if a 10 volt is applied to a parallel combination of R1 and R2? The total power. So please do not do 10 over 220 plus 120. So if you want to do it like that, you'll have to do it. P1 would be 10 squared, which would be 100 divided by 270, plus 10 squared plus 150. So you'll find that you'll get 1.04 watts. Or you can find the R total, which will be, if you use the special formula for two resistors, will be 270 times 150 divided by 270 plus 150. That value you will have to say later 100, which will be 10 squared divided by the result of the R total, and that should give you the same answer, just because we know that the P total is equivalent to the summation of each individual powers in the circuit. So let's go ahead and continue with some more examples. So here it says, assume that there are 8 resistive wires that form a rear window defroster from an automobile. If the defroster dissipates 90 watts when connected to a 12.6 volt source, what power is dissipated by each resistive wire? So they are telling us that we have 90 watts. That's our P total, right? So, and then we have our voltage source. So because they are saying that they are a resistive wire, so we have to divide the P total by the total number of the different wires, in this case 8. So that's going to give us that each wire, resistive wire, would dissipate 11.22 watts. Now from there, we are going to go ahead and find the total resistance. For A, we find that it was 11.25. For B, what is the total resistance of the defroster? So we know that P total is going to be B total over R total. So we solve for R, we have our voltage source, we have our total wattage usage, and then we divide that and we get that the defroster total resistance is equivalent to 1.76 ohms. Now, if we want to say what is the resistance of each wire, what is the resistance of each wire? So we have our R total. Now we have to say that this we all do it by hand, so you know how I got this value, okay? So let's move on to some definitions. What is a parallel circuit? Like I said before, is the relationship in an electric circuit in which two or more current paths are connected between two separate points, which are nodes, branch. One current path in a parallel circuit, Kirchhoff's current law, a law stating the current into a node is equal to the current out of the nodes. What is a node? A point or junction in a circuit at which two or more components are connected. Current divider is a parallel circuit in which the current divides inversely proportional to the parallel branch resistance. So that concludes our chapter 5. So we are going to stop right here.